heights of college women is a normally distributed variable with a mean of 63.5 inches and a standard deviation of 2.5 inches. What would be the z-score of a woman who's 66 inches tall? A normally distributed variable makes a bell-shaped distribution, where there's some average around which most women would be measured. And they're saying that that mean is 63.5 inches. Now, if we were measuring all people in college, including males and females, we wouldn't get a normal distribution. We would get instead what's called a bimodal distribution, because there's this phenomenon called dimorphism of the sexes, where sometimes we can have different average characteristics for each. So where it might be that women would have one average, men could have some other average, and so we would get two humps to this distribution if we were to measure everybody. So, here we'd have female average, and over here you might have another peak for males. So they're only measuring females, so we'll get a normal curve. Now, as we did in the past, we want to mark one standard deviation above the mean and one standard deviation below the mean. We'd like to take that 63.5 and add the 2.5. Okay, so we're going to find mu plus sigma is what it's called, where this is the average and this is the standard deviation. So you add them two together, you get 66. If you subtract over here, you'll get mu minus sigma. That's going to be 61. Now they're asking, what's the z-score of a 66-inch tall woman? Yeah, it's going to be 1, because on our z-scale, we said before that the mean has a z of 0, one standard deviation above has a z of 1, and one standard deviation below has a z of -1. So yeah, the answer to this one is 1. But we also want to be able to use the formula for z-scores to find that. So the formula for z-scores says you can always calculate the z, and it's going to be x minus mu over the standard deviation. That's a formula we'll use a lot in the future for calculating z-scores. So let's try it on this problem. For this problem, the x is the 66. That is the woman in question that they're talking about, because they're saying, what is her z-score? Okay, so let's calculate it using the formula. We'll do 66 minus 63.5, because the mean is 63.5, and then divide by the standard deviation of 2.5. If you do that on calculator, you'll get a z of 1. Okay, now not every woman is going to fall exactly on one of these important points in the curve. So let's look at the next question. This one says, heights of college men is a normally distributed variable with a mean of 69.5 inches and a standard deviation of 2.7 inches. What would be the z-score of a man who's 75 inches tall? We can draw the curve for men. The mean is 69.5. And if we add 2.7 to that, I get 72.2. If we want to go farther, we could get 2 standard deviations above the mean, and that's 74.9. But this man in question is not 74.9. He's a little bit taller than that. He's 75 inches tall. So how do we get his precise z-score? It's not going to be 0, it's not going to be 1, it's not going to be exactly 2 either. So this is where we would want to use the formula. So the formula says his z-score will be his x minus mu over the standard deviation. You go ahead and try to calculate it for yourself for a moment, and then I'll give my answer as well. Alright, let's plug it in. We want 75, which is the man in question's height. The mean was 69.5. Then we have to divide by 2.7. Approximately 2.04. We'll usually round z-scores to the 100th place. That's pretty common. Yeah, so his z-score is just a little bit more than 2. So he's actually unusually tall. Anything over 2 standard deviations away from the mean is unusual.